Hey guys, welcome to my new video. I'm going to be showing off my signal generator, or my badass signal generator, as I do say so myself. So it's a pretty cool project. Let me give you a bird's eye view of this thing. Everything here was done by me, so everything from design, prototyping, schematics, board, which includes placement, routing, layout, fab, everything. Even soldering was done by me. So it's a pretty intensive project overall. It took me almost 2 semesters to actually get this done, including the firmware and everything too. So let me get straight to it. It's pretty much what it sounds like. It's a signal generator, single channel. It goes up to 5 megahertz and it offers triangle, sine, and square waves as output capabilities. So right now I'm running on manual mode, so you can actually tune your frequency, your amplitude, and your offset manually, along with this toggle button and this array of switches over here. So just to give you an example, oh, by the way, I've got my analog discovery kit over here, which is pretty much my crappy oscilloscope, which I have to use. Can't afford something better than that, so hey, what can you do? Student life. So, just to give you a demonstration, if I was to press and hold the toggle and start altering my frequency, you should see something pretty damn cool. At least in my opinion, pretty damn cool. And this switch over here allows us to go from sine wave to square wave, which is unfortunately a little bit ringy right now. I have found a solution to this, but it needs some rework, as well as triangle wave capabilities, which is really cool. And so one of the best features, in my opinion, is the fact that you can hook this up over Ethernet, over here, and it goes whoop, straight into my MacBook. And you gotta flip the switch first off as well to go into Ethernet mode, but pretty much what this allows you to do is open up this website, which is hosted over your local area network by the microcontroller, and tune whatever things you want. So for example, let's go to 10K on a sine wave, and once I press OK, there you have it. So now I'm going to just talk about its actual frequency deviation, its amplitude and offset. So looking at its amplitude, you can tune this through the board itself, through one of the many potentiometers I put on there. Let's put this back to 2 volts peak to peak. And you can also do DC offsets as well. And as mentioned, this thing does run up to 5 megahertz. It doesn't work perfectly at 5 megahertz. It has a lot of distortion, but hey, it's good enough for my cases. So let me show you 1 megahertz for now. And let me change the division on this thing as well so you can actually see it properly. Come on. Oops, actually that was 10 megahertz. Whoops, I don't even know how that's working. So that's 1 megahertz right there. As you can see, it's a little bit more ripply. You can see some distortion in there, but it's still pretty good for 1 megahertz wave. For a chip running on 16 megahertz as its reference. So if you were to go to 5 megahertz, you will see some noticeable attenuation, which comes from my reconstruction filter. My reconstruction filter is a second order Sallen-Key active filter. It's Buttersworth. So it does have a 3 dB point, which is why you can see about 0.65% of the peak to peak voltage getting passed through. And something really, really cool that I do want to show off as well is the fact that if you go to 8 megahertz, which is essentially this chip's Nyquist max frequency, you will see amplitude modulation. And this occurs based off of the delta frequency, which occurs through the reference clock, this reference 16 megahertz clock, which is used by the chip, as well as the internal PLLs and the 8 megahertz output. So that little delta frequency actually creates this modulation. Anyways, so yeah, just a little bit more about the board itself. I've used, over here you can see the switching supplies, the switching boost regulators, as well as low noise, ultra low noise linear regulators. Over here I've got virtual ground generation techniques. This is my DDS, which I unfortunately had to deadbug. It looks really nasty because it was a QFN package, and I just glued all over it simply so it wouldn't be so fragile. And over here we have my analog output stages, which does all the reconstruction filtering, the high pass, low pass stages, amplification, DC offsets. And finally over here I've also got my just things to help with output interfacing, making sure you got matching networks and so on and so forth. So for example, if you got a BNC cable connected over here, you can tune this potentiometer here to give you 50 ohms of output impedance. So yeah, it's a pretty damn cool project. I definitely loved it. I don't know about you, but I sure did. And thanks for watching the video. Hope you guys liked this. If you got any questions, leave a comment or just email me or whatever. I'll be there. Peace.